it goes back to why should we care about who controls the data? We create it, Google collects it, Amazon collects it. They know the ways to monetize it. We get a good service for free. Seems like a reasonable deal. But it really does matter who controls your data, because if you don't control your data, if you don't participate in the value that is created from your data, you have very few incentives to actually create high quality data. The consequence of this can be seen in the data that we have today. When you just look at data that is used for AI training, which is probably where it becomes really valuable these days, only 3% of the data that is out there is deemed acceptable by managers in terms of the quality of the data, so that you could actually use it to train these kind of models. Only 3%. There's very large markets out there that depend on high quality data, not just for financial reasons, but it's also about data in healthcare, data in research more generally. So the quality of your data, of the data that is out there, is really not up to where we need it to be, and that is a problem, a real world problem. So when you try to trace it back as to where does this problem come from, it really goes back to the question of who controls the data. At the moment, if you want to share your data, let's say there's two firms, A and B, and they want to share their data because the combined data set is much more valuable than the individual data sets, which is exactly the case whenever you do any kind of analytics with it. They're really faced with a conundrum, because either firm B shares the data with firm A, meaning it sends it to, and if you want to sort of use it in a joint data set, firm A needs to have some form of access to the data, which is a problem for firm B because they do not easily control how that access to the data is used. So the solution that we have today is that we're writing large and complex contracts about how firm A can use the data of firm B. GDPR and like the California privacy regulations make this even more costly and complicated. The only other way they have is to both share their data with a third party that then combines the data into a single data set. That's basically the Facebook and Google model. They sort of combine everybody's data and monetize it, but they control this data. And that is really a problem. What you would like to have is a system where firm A and firm B together control their data and jointly decide how it should be used, not a third party, and not needing, complex, hard to enforce, in many cases impossible to enforce, legal contracts. So this matters in particular for research. Every researcher here who has done empirical work will have faced the problem that there's these like amazing data sets that you would like to analyze, but you can't really do it because in order to do that, you would have to combine them. In order to combine them, you would have to have access to the underlying raw data, often including personally identifying information, which is restricted by GDPR. And as a result, a lot of the data that you would want to use and that you maybe even have individually access to, you can't use to the fullest effect because you can't guarantee, you can't prove that you won't use the data in any other way than what is sort of part of a research proposal. The consequence, and this is a very real practical consequence, is that a lot of the data that could be used for research just isn't used. I was at Bundesbank for a very long, the German central bank, for a very long time. We collected data through different departments, banking statistics and banking supervision. These two departments were not allowed to legally combine the data, even though it was within the same institution. The solution was to create a completely new research center that has legal authority to do this. It took like 3 years, 5 legal experts to actually craft this whole thing, because the question was always about this residual control over data. And why residual control really matters is more from a legal perspective. So let me just do this like very slight detour into the legal world before going back to the technology. And that is this question of control versus privacy. At the moment, the way that we govern data is largely a privacy issue. We treat it from a privacy perspective as part of GDPR, not from a control perspective. What that means is that we have privacy as a recognized human right, but the way that it's defined is always about the correspondence of information, about the communication of information, you telling somebody else your data, which goes back to this definition of privacy in the Alan Weston, for those of you who are in this literature sense, where privacy is the claim of individuals or groups or institutions to determine for themselves when, how, and to what extent information about them is communicated to others. So the definition that most lawyers sort of apply, and that the courts in the US, for example, have applied over and over again, and that the Warren and Brandeis sort of definition of the right to be let alone ties directly in. That is a definition of privacy as control over communication. Basically, I can reveal information to you, or I cannot. That is the right I have. But it's a very limiting right. It's a 1-0 thing. It would be much better if I could reveal the information to you and give you the right to use it for non-commercial purposes, but not for commercial purposes. The reason why we can't do that at the moment is because you have no way of proving to me that you're not using the data in any way other than what we agreed upon. And that is a problem. And I think it has to do with this focus of privacy on communication. In any information infrastructure, following the technical definition of an information infrastructure, you have 3 components. You have information, communication, and computation. Those are very different from one another. Restricting our ability to control data to only one of those dimensions is by its very nature limiting. And it disenfranchises us of many of the rights that we would have to our data, many of the control rights that we would have to our data. As an economist, this really matters, because the economist's definition of ownership boils down to residual control rights. Who decides what happens with property or chattel, movable property, in the situation where the contract doesn't apply? And contracts are pretty much always incomplete. That's the heart of Oliver Hart's Nobel Prize in 2016. So whoever controls these residual rights is the owner of the asset. In the case of data, it's really problematic, because it means that if we share data, I lose the residual control rights, because you could do with the data whatever you want, and I have no real way of finding out or enforcing control of it. And as a result, ownership transfers. So data has been always treated as a non-rival good that is basically free to copy, impeding individual ownership, meaning we don't have really good data marketplaces, and we struggle to create sort of data ecosystems. So this is the situation that we have today. So in the remaining, I don't know when I started. Do I have 7 minutes? Okay, that's 5. Cool. 6, 7 minutes. Okay, so in the remaining 6, 7 minutes, just want to show you one approach that we have used in my group and at the University of Cape Town, where I was for 10 years before just moving to Frankfurt, about how you can control your rights, control your data through digital rights tokens. And the combination that we've sort of built is a system that uses secure enclaves as a privacy engine with all its downsides. So if you're a privacy researcher and you're offended by somebody using TEEs, come talk to me. We have some thoughts on when you can and cannot use it. An Oracle layer to connect the TEE with the blockchain, and the blockchain as a rights recording mechanism. And the reason why we do this using blockchain is because it's the only system that doesn't have a centralized control point, because every centralized control point means that the residual control over this right that you are recording sits with somebody else. If I record my rights in a database, whoever operates this database can block me from using the data at the very least. In some cases, they can duplicate entries in the database. They can find other ways to sort of manipulate the rights that I have issued. Blockchain, by virtue of solving the double spend issue, prevents exactly that one thing. So if you create a data, and this is the system that we built. So sorry for that's a reason I don't like PowerPoint. It sometimes messes up your fonts without you realizing it. I apologize. So the system that we built and that we continue to build is a system where you can upload your data into a vault. So there's a website basically. You can upload your data in a vault. This sets up a smart contract that manages the rights to this data. And this rights management includes reference to a piece of code that can be executed to the data. So then you can grant a right that says other people can also contribute to my data vault. So you set out the standard for how the data looks like in your vault, and whoever buys the right or whoever acquires the right to add to it, they can just append their data, and it's sitting encrypted with a private key of the trust execution environment, so that neither the operator of the infrastructure nor anybody else can see the underlying data. The TEE then uses the Oracle layer to connect with the blockchain, and whenever it recognizes that a right is sent to that somebody acquired a right to do code execution, computing the median of something, for example, This is sent to a smart contract that manages your data pool. The blockchain recognizes this transaction. The TE sees this through the Oracle layer and then executes the code that is referenced in this token. The result of this computation is returned to whoever redeemed the digital rights token. And in this way, you can prove to the data creators that their data has not been used in any way other than what they specify in the digital rights tokens. And this really matters because it changes the notion of ownership of data. And it changes, in essence, the nature of data from a non-rival to a rival good. So it means that this kind of infrastructure, and there's other implementations of this possible, I think, but this kind of infrastructure makes it possible to change the nature of how we look at data. So this is really, I think I'm going to skip this just because of time. I think this system has all the components that you need to create this new kind of information infrastructure around your data. So you see that this is not just pie in the sky kind of random stuff. So we actually built a simple implementation of this. I can promise you this is not me being dyslexic. There's the PowerPoint is not to be trusted here. So we built this for a non-custodial digital asset wallet that we worked on with Ripple for their CBDC pilots in Palau and Bhutan. So we basically built a wallet that is non-custodial because we can prove that we don't control people's keys, signing keys for blockchain transactions, that is integrated with XRPL, and that allows you to do push and pull payments, recurring payments, that allows you to find your counterparties by their phone number or their passport number, and then send transactions to them. These are practical problems that non-custodial wallets cannot solve in any other way these days, not at scale at least. So we built this app where you can go and you can start initiating transactions using this privacy-preserving tech stack underneath it. So you can go, even if you don't have a smartphone, which in Africa is more than half the population, you go to somebody who does have a smartphone, you have a QR code to identify yourself. It scans the QR code, hands you the phone, and then you need this privacy tech stack to make sure your keys aren't intercepted and the signing of transactions still works. So you can go to a connector, set up an account, you can start creating this digital asset wallet. We have an integration with XRPL and also with Algorand. And then you can start making transactions to other people that have accounts. You can look for their names and send money to them via their name. And this allows you to have at scale, and this was tested for up to like 1,000 transactions per second, at scale, a digital asset wallet that doesn't require the custodial setup, which means it's exempt from a lot of the regulations that we have, that doesn't impede the control over your private signing keys, and still enables people without a smartphone, again, the majority of the people in the world does not have a smartphone, to participate in blockchain transactions. We ran this for like a proper real-world test with Algorand a few years back for the South African retail CBDC. It worked fine. I think it's one of the few ways that I've seen where you can bridge sort of this universal access problem and get people who don't have smartphones the same kind of control over their keys that people with smartphones have. And it's only possible because of this underlying idea of data control. So with that, if you're interested in this, happy to chat further, but I think I'm out of time.